All right, so let's talk about how web application works. And to understand this, we have to go a little bit in depth and explain what's called an HTTP request and response. But in that process, we'll understand how all the different technologies work together. So here, I put together some list of technologies that you may have heard of. And if you are trying to learn how to code for the first time, it could be very overwhelming to know what are the different things that I should study when there are hundreds of things that kind of begs your attention. So the purpose of this video is to help you understand how all of these different technologies work together. Without having a framework in mind, it's hard to know how all of this fits in. This video could also be really good for entrepreneurs or recruiters or hiring managers, developers, to see how all the different pieces work together. All right, so if you look a little bit more into these technologies, you may have heard of PHP, Python, Ruby, Node.js, C#, and then HTML, CSS, and the list goes on. RESTful API, cloud services, Docker, containerization, Jenkins. What does that all mean? Cucumber, TDD, right? Again, there are just so many technologies out there that without having a framework in place, it could be very, very overwhelming. So what I'm going to do is I'm going to use an analogy. And this analogy is called the Ikea store analogy. And this analogy has helped me to teach this concept to a lot of my former students when I was running Coding Dojo. So I hope this analogy is helpful. It will help you see a bigger picture of how everything works. And using this foundation of the IKEA store analogy, you can also figure out how to tackle any scalability issues that your web applications may be having. So I'll introduce those concepts later on. But for now, let's go and get into the IKEA store analogy. All right, so I have my iPad over here and just a very simple drawing app that we can use to illustrate how this works. So before we talk about web applications or web servers, let's use this analogy first. So let me introduce this IKEA store. It's not a real IKEA store, but I think when I say IKEA, you can kind of picture how the IKEA store looks like. It's a furniture store. So let's say that our IKEA store looks as follows. And as you guys may know, I love just a blank white screen and a whiteboard because this is how I was taught, and I just love the simplicity. I don't like PowerPoint slides, so I like to just draw things. All right, so let's say that at this IKEA store, the way that it works right now is, let's say there are 3 lines of customers. So these are customers, and they're waiting in front of my store. So this is my IKEA store. Now, let me just erase some of these dots. Now, at this store, the way that it works is I have 3 receptionists. Sorry about my bad writing. Just listen to my words and see if you can follow along. So these 3 receptionists handle the 3 lines of customers. There is a receptionist per line. And then what happens behind the scene is, so first of all, customers walk in, and they fill out an order form saying, okay, IKEA store, these are the furnitures that I would like to buy. They hand that order form to the receptionist. The receptionist takes that order form and gives it to the workers. So let's say at this particular IKEA store, we got workers who speak, let's say, Mandarin, okay? And they speak Mandarin to each other. They take the order form, and using Mandarin, they communicate with each other how they're going to fulfill the order of the customer. And they do that using Mandarin as a way of speaking to each other, communicating, assembling furnitures together. They do that using Chinese. Okay, so using Mandarin. So we'll say that they are speaking Mandarin right now. And then there is a warehouse, and this warehouse has a lot of cabinet drawers. So just imagine that there are a lot of different cabinet drawers over here. And these different cabinet drawers are used to store different parts. For example, maybe some of the Ikea chair legs, the silver legs, black legs, white legs, the tabletops, different lamps, all the different parts that are used to assemble the furnitures are all stored in these cabinets. And there are lots and lots of cabinets and drawers where you can store inventories. All right, so again, customers wait in line, they fulfill the order, they talk to the receptionist. The receptionist gives that order form to the workers who speak a specific programming language. Well, went a little bit early, but they speak a specific language. And then they go to the warehouse, and there is a warehouse manager who speaks a different language. They speak the warehouse language. And then the parts are stored. The warehouse manager goes and retrieves the parts, gives the parts back to the workers, and the workers speaking that language assembles the furnitures together, hands it off to the receptionist, and the receptionist hands it off to the customer. Okay, so this is how my IKEA store works. Okay, pretty simple. There's a system in place. All right, so what does this mean for web application, and why did I introduce this? I gave a little bit of hint that these workers speak a language, and the analogy of that language is a programming language. But how does this relate? Before we tie in some of this analogy together, let's step back and look at a higher picture. All right, so all of us are used to opening up a browser. This is my browser. This is where you type in. So you can type in, for example, let's say you typed in hackerhero.com, which is the education platform that I'm using to teach people. So you type in a URL into the browser. And what happens? What's happening actually behind the scene, behind the browser? Well, what's happening is this sends a request. This is called the HTTP request. And it needs to go and find the place to the computer that has this hackerhero.com or CNN.com or whatever site that you're looking for, right? How does it find it? Well, the way that it works is there is this server called DNS server. And we're not really going to go too much into how this server is built. But the DNS server, the way you can look at it is like a phone book. What it has, just imagine, list of all the domains in the world, like CNN.com, ESPN.com, hackerhero.com, and so forth. And it maps the IP address, okay, or the address of the computer that hosts that information. Well, what is an IP address? It's really easy to think about this. Just like how every single house or office in the world has a specific residential address, so that if you want to write a letter, you write a letter and say to, and then you write the residential or the commercial address, and the mailman knows where to deliver that mail to. Just like that, every computer, that's computer, all these rectangles, in the internet or in the cloud, right? Because cloud or internet is basically just a bunch of computers connected as a network that you can kind of think of the internet as that way. Trying to simplify. So all the computers in the cloud have a specific address, just like every single house has a residential address, and that's called the IP address. And the IP address is usually composed of numbers separated by a dot. So this CNN.com could be, for example, 25.135.92.78. And if you type in CNN.com into the browser, then the DNS server says, okay, you need to go and talk to this computer. Okay, and that is kind of how web application works. All of this is a server. Okay, so now how does the analogy come in? Okay, this is basically the IKEA store that we talked about. So when you put in a request to in the browser, it looks up the DNS server and it finds that computer with that IP address. What's happening? So people, you're not the only one who's sending the HTTP request, right? So a lot of people are sending requests, and the server basically says, so I'll say this is the server, basically says, wait in line. So imagine that there are 3 lines of people who are waiting to get information from the server. And they filled out the order form. The order form is basically the URL. Or if you're looking at hackerhero.com/game/learn-to-code, then that's the order form. I want information from this URL, right? So a bunch of people are waiting, having filled out their form, and this is again called the HTTP request. It's basically the order form that the customers filled out. And then there is a program called web server. Okay, web server. It's confusing because this receptionist is also called a web server. Sometimes this whole store or the server is also called a web server. It's a little confusing, I know, but just bear with us and it will make more sense. Okay, so the server takes the request, sends it to the workers, and just like in the Ikea store, you could hire Mandarin workers, English workers, Spanish workers, Italian, Korean workers. The server in the computer can have people, the workers who speak, for example, PHP, Ruby, Python, C#, Java, Node.js, and there are just a bunch of different programming languages that you can use. Now, let's step back at a high level. Think back to the Ikea store. If you're the customer at the Ikea store, does it matter that the workers are assembling furniture speaking Mandarin, English, Korean, Spanish? It doesn't matter. What language they use to assemble that furniture, as long as the furnitures come back good, it doesn't matter, right? Same thing over here. For the web servers, does it matter? Does the customer care whether ESPN.com or CNN.com was built using PHP as a language, Ruby, Python, C#, Java, Node.js? It really doesn't matter, right? Because all of that is happening behind the scene. And in fact, if you take some of my other courses, you will see that all of these programming languages boil down to what I consider 5 core building blocks of software. And everything can be built using those 5 building blocks anyway. So I'll introduce some other analogies to explain. But let's go back to this analogy. So the workers can assemble the furnitures together. They can also go to the database. Database is where all the different informations are stored. For example, all the popular news of the day are archived in this. Or products that your website is selling. Or some of the other information, the messages that your users are sharing with one another, is all stored in these cabinet drawers. Okay, so let's zoom into the database and think about this. In the database, let's go back to the IKEA store example. Imagine that I had this IKEA store set up for the first time and I hire you to be my database manager. And I say, hey, look, I have a lot of different parts and I want you to organize these inventories the way that you think it should be organized. And you say, okay, Michael, I'll go ahead and do that. Imagine that not only I told you to do that, but I hired 10 other database managers to go in and do the same thing with the same instruction. Do the best. Use what you know to organize these inventories the way that you think should be organized. Now, will all 10 of you or 11 of you all come out with the exact same way of storing those inventories? Will you all organize your cabinets and put some of the parts on the left side and then on the right side, and will you all be organizing it the exact same way? No, you won't, right? Because all of you will have different opinions about how things should be organized. Okay, that's why, again, when it comes to the database, there are so many different databases out there just because a lot of people have different opinions about how things should be organized. Okay, so when you hear a lot of different databases out there, don't get overwhelmed. Just think, oh, it's just a way that someone thought the information should be organized. Now, some people said, okay, I'm going to optimize so that when we have lots and lots of data, I'm going to optimize my database to be efficient for that. So they created some databases optimized for that. Some people have optimized for different things, again. So coming back to this analogy, this is why there are so many different databases out there, because there are a lot of different opinions about how data should be organized, just like how there will be a lot of different opinions of how the Ikea store furniture should be organized. And there are also different objectives or different goals that the database was built. Some for small amounts of data, large data, big data, really big data, right? So Hadoop is an example of a large data. Oracle is an example of a large data too, and so forth, okay? All right, so the database, they store the parts, they give it back to the workers. The workers assemble things together, they give it to the web server, and the web server gives it back. The web server here, for example, if you have heard of Apache, Tomcat, WebBrick, Nginx, those are all examples of web servers. Some of the web servers are built to work with specific workers. So for example, with Java, you will see that some of the web servers are built to work with Java. So Tomcat being one of the example. Unicorn, WebBrick, or web servers built for Ruby. Frameworks. And some of these can work with multiple languages, such as Apache, HTTP, and so forth, Nginx. But there are multiple web servers that work with these workers. All right. Now, in this example, what does the furniture mean? Right. In the web world, the furnitures, the assemble furnitures are basically HTML, CSS, and JavaScript. Okay, I'll write JavaScript on the top. Regardless of any web application, regardless of what language the workers are speaking, regardless of where the information was stored, regardless of what web server types were handling the HTTP request, at the end, all of these web applications produce HTML, CSS, and JavaScript. Now, I'm kind of simplifying. There is another format such as XML and JSON that these web servers would produce, but that's kind of what you see behind. You don't see that as much. 99% of what you will see will be HTML, CSS, and JavaScript. What are these? If you go to the browser, the text that you see, the easy answer is, the text that you see is the HTML. Now, certain text appear big, red, has an image, is beautiful. All of that is CSS. Anything with the appearance is CSS. Now, sometimes when you click on something or you hover over or there are some interactions, pop up, all those things, that's JavaScript. JavaScript handles the interaction. HTML is the text. The CSS is the appearance. Okay, so now let's go back to this example a little bit more, and let's go a little bit more in depth. Okay, let's look at the workers first. Again, I want to emphasize this a lot, that sometimes people put way too much emphasis on the programming language, but you shouldn't. You really, really shouldn't, because after all, does it really make a huge difference whether you hire English workers versus Mandarin versus Korean? After all these languages have similarities. And if I said, hey, you should fire all your Korean workers, I'm Korean by the way, you should fire all your Korean workers and hire English because they're 20% faster? Okay, come on. I mean, does that, maybe, but even if that is true, later when you learn about some of the other scalability issues, you will find that even if they are a lot faster, it usually doesn't make that much meaningful difference in web application. Okay, but overall, kind of simplifying things, there's not really that much difference. Now, the difference sometimes comes in the tools that these workers come with. All right, so imagine that, for example, if you're using PHP, other developers built tools that come with PHP. So they built that tools using PHP, so using the core building blocks of software that's available in PHP, they created these tools and frameworks. So And sometimes they spend years refining that toolboxes. Okay, so imagine if you hire PHP workers, they will come with their own sets of toolboxes. And if you hire Ruby workers, they will come with their own toolset toolboxes. C#, they will come with their own toolsets of toolboxes. And these toolboxes are unique. And people spend years refining these toolboxes. So sometimes you will find PHP and certain framework, and it will have some of these awesome toolboxes that make some of the assembling of furniture easier, right? Now that used to be the case, I would say, back in Web 1.0, maybe even in the early days of Web 2.0. But now, as developer from one language have moved on from that language to another language, the best practices for how to build web application have really spread a lot more than it did years ago, or 5 to 10 years ago, and is continuing to converge. So now the differences between the toolboxes of PHP versus Ruby versus Python versus C# versus Java are not really that different, because again, now developers had more time to learn of different toolboxes, and they're becoming very similar, which is why the best developers are programming language agnostic. Because again, all of these toolboxes, after all, could be created using the core building blocks of software. In fact, when I was teaching at Coding Dojo, as one of the assignment for people who have been coding for about 5 weeks, only 5 weeks, one of the assignment is to create a framework from scratch. And then they do it in a single day. So in fact, all these toolboxes, for example, for PHP, there is Zen framework, there is Cake PHP, there is Laravel, there is E framework, there is CodeIgniter. And then not only are there a bunch of frameworks, and again, one of the ways that you can think of frameworks is just collections of tools available for these workers. Some are called MVC frameworks, because the way that you organize the workers is to say, do you know what, let's divide our group into 3 teams. One team that handles models, which is basically anything that has to do with the database. You're going to be in the M team. Okay, anyone that puts together the furniture together in HTML, CSS, and JavaScript, you're going to be in the views team, because that's what the customers will view. And then we're going to have controller team who controls information in between the models and the view. It's called an MVC framework. So again, just some framework, some opinions about how the worker should be organized. And this MVC framework kind of became the standard for creating web application. But it's just a way of organizing the worker. Now I can say, do you know what? I don't like the MVC framework. I don't think workers should be organized into 3 groups. I think they should be organized into 5. Someone else may say 7. Someone else may just say, just have them all just do everything. Just different opinions. And I can go and create a new framework at the basic foundation, probably in a day or 2. And then if I spend more time, then I can also give it a name and then add another technology on top of what is available for the world to use. All right. Rails, for example, some of the Ruby is Rails, Sinatra. For Python is Flask, Pylon, and then Django being one of the most popular framework for Python. C#, .NET, ASP.NET, .NET Core, and so forth, and so forth. Okay, so let's do this actually. Let's go back to this to see how all of this kind of works together. Okay, well, let me just do one more thing before we look at the list of diagrams that we saw. Okay, let's look at this bucket now and analyze this more in depth. Okay, remember that I talked that all web applications in the world, at the end, regardless of what programming language they use, regardless of what database they use, is just it just produces the furnitures, which is HTML, CSS, and JavaScript, right? Now, you would have noticed that web applications have really become a lot more complex over the years. And there's a lot more interactions within the web application, which means a lot more JavaScript, right? Because JavaScript handles interaction. So imagine if you got a lot of developers and they're all working on JavaScript, it could get overwhelming. And you kind of need to organize these. Just like imagine that I give you 1 million photos, and you have to organize that. I mean, or you have to browse through and I say, oh, look for that file, and you open up that folder, and then there are 1 million photos, you would be overwhelmed, wouldn't you? So you want a way to organize some of those codes or those photos into neat buckets, right? So imagine JavaScript. Its application is really complex. It's 1 million lines of code, which is analogous to 1 million photos. You want a better way to organize that. Otherwise, everyone's going to get confused. So now there are toolboxes or ways of organizing your JavaScript code to make it neater. And this is, for example, where Angular comes in, React, Ember, Backbone, Vue.js. And all of these libraries are basically just ways of organizing your JavaScript code. Okay. Now, I have to emphasize some of these principles over and over again. Maybe it's the teaching side of me. Again, think back to that example. Imagine that I gave you 1 million photos and told you to organize it. And imagine I got 10 other people and said, you also organize these 1 million photos the way that you think it should be organized. Are you all going to organize my 1 million photos the same way? Probably not. Some of you may organize it by the years and the month. Some of you may organize by the area that the photo was taken. Some of you may organize it by the name of the person that appears in the photo. Which one is the right way? Well, they all could be the right way, right? That's why in JavaScript or in PHP, Ruby, Python, any language, all these frameworks are mere opinions of some of the people. And again, not only is it opinion, it's very easy to create a new framework and give it a name, which is why there are so many frameworks, okay? I'll come back to that analogy, but let's come back to the JavaScript. So again, there are a lot of different ways you can organize the JavaScript. So Angular has one philosophy about how your JavaScript should be organized. React has another philosophy about how things should be organized. Ember, Backbone, Vue, and who knows? Someone can just go and tomorrow create a new framework and say, I don't agree with all of them or any of them, and I'm gonna create my own new framework and add one additional list of technology in an already what seems to be a confusing place, right? Okay, so now let's go back to this one. Okay, so now when you look at this, I hope it will be a little bit better. So for example, the PHP, if you look at the top left bucket, PHP to COBOL, those are the different programming languages. Okay, some of the languages such as Fortran and COBOL are not used for web application, but I just put it there to indicate these are just the different programming languages. You can see HTML, CSS, and JavaScript. That's the final furniture, right? There are ways to better organize your CSS, which is where less sass comes in. There are ways to write your JavaScript code a little bit more concise, which is TypeScript, CoffeeScript. There are, there's a typo, but there are tools available, existing CSS libraries you can use. That's where Bootstrap and Foundation comes in. React, Angular, Ember, Backbone, Vue.js are just JavaScript frameworks to organize your JavaScript code a little bit better. Jasmine, RSpec, Capybara, Cucumber, Protractor, PyTest are tools that come with each specific language. For example, Jasmine is for Node.js, RSpec is for Ruby, Capybara, Cucumber can be used with some other things. Protractor is usually for JavaScript and also with Angular in it. PyTest is for Python. So every single programming language can have sets of tools where you can test if your code is working. Okay, just additional toolboxes. And each of the toolbox with each programming language comes with a new name. Laravel, Coding Natter, Zenke, PHP, Symfony E. Those are frameworks available for PHP. Pylons, Django, Gyoto, and you can go and list. There will be dozens and dozens more for PHP. Again, someone good can create a new framework in 2 days or less. Those are frameworks for Python. Rails, Sinatra are frameworks for Ruby. Express framework for Node.js. ASP.NET, .NET MVC Core. Those are frameworks for C#. Spring, Struts, Hibernate, Play. Those are frameworks and tools available for Java. Okay, Ajax RESTful API or MTDD. Some of these are, I would say, just tools for these workers to use. And later when we talk about how you have multiple web services or microservices. We'll talk about how some of these technology come into play. The front end, that's again HTML, CSS, and JavaScript. That's front end because that's what people see outside the store, outside the Ikea store. Back end is what happens inside the server or inside the Ikea store. So the programming languages, the web servers, and the database, all of those are back end. HTML, CSS, and JavaScript, and tools related to that is called front end. Okay, SQLite, Postgres, MySQL, MariaDB, Oracle, Hadoop, MongoDB, Cassandra, Access, Redis, they're all different databases available. They're very similar to each other. Once you know one, you can kind of learn the other pretty quickly. Although there are some differences between what's called a relational database and non-relational database, but we won't really get into that. Some of these databases are stored on hard drives, disk. Some of these are stored in memory. So Redis, for example, is a memory-based. So even you don't care if the server, you lose the data, even if the server has to restart, because you're sharing some real-time information and you don't need to store it permanently, then Redis or Memcache are good examples, because storing things in memory is a lot faster than storing on disk, right? So those are some examples of why there are different databases out there. Amazon, AWS, Rackspace, Azure, Google Cloud are places that you can rent these computers, and they have different services available. Docker, Kubernetes, Amazon RDS, Hive, ECS, Fargate. These are, once you buy, just kind of imagine this. Once you buy a lot of computers, right? Because imagine that you got a single computer, which I demonstrate in this Ikea store, but now a single computer is just not powerful enough to handle all of your website traffic. Then you want to get multiple computers and you want to orchestrate how these multiple servers work together to provide a harmonious experience to your customers, right? So that orchestration requires some what's called kind of a service layer on top to just orchestrate and manage all the different Ikea store so that they all work in harmony with each other. So some of these tools, just kind of think of that as services offered by these big, giant cloud services, where, for example, let me manage your database for you. So that's Amazon Relational Database System, and so forth. But just know that there are a lot of different services out there to help you manage if you're one store is not enough and you need to have multiple stores to handle your large traffic. Elastic Beanstalk, those are kind of similar services available when you have a lot of different computers and you need to manage that. And Git and GitHub is just a tool that the developers use to organize their code and collaborate with other people. So again, this may have seemed a little bit overwhelming, but if you go back and think back into the Ikea store analogy, and it's a little bit complex with all my writing, but I'll also put a link so that you can read the article that has kind of more neat drawing than what I did on this. You will understand, okay, how all of this fits in. It's really not that hard. If you think back to the Ikea store analogy, everything will fit in to either the receptionist here, or it will do things with the workers and the tools that they come up with, and then it will also do things with the database, and there are technologies over here. So again, this is the front end, and all of these are the back end. So we did cover a lot of concepts, didn't we? We covered about what an MVC framework is. We covered how web applications work. We talked about IP address. We talked about DNS server. We talked about different programming languages, frameworks, tools, databases, web servers, and all this. But again, if you use a good analogy and relate back to this analogy, I hope this would have helped you to at least see how everything fits together. Okay, all right. So I'll have some other videos you can watch where you can learn about, okay, what do I do when my web application has a lot of traffic? How do I scale? Okay, so that will be the next extension of this. Okay, thank you.